All right, so this is an update to the MCO Compact 5 servo from the printer port conversion. Again, this is Linux CNC outputting pulse density modulation to the servo reading back to the printer port with its encoder. And so we have a true closed loop machine where Linux CNC is doing the PID stuff. So I mocked this up to see, before I made, this is 3D printed, this is 3D printed, this is 3D printed. I wanted to see if it all kind of fit together before I actually make these out of steel. And so far it looks pretty good. I might have to make this just a little thinner here. I sanded it down a little bit, the plastic, but it's a tight fit, but I think it's going to work. It might be better to move the ball nut out just a little because I think I have a little bit of room here. So, yeah, so far so good. If you look up in here, you can see the timing belt going to the ball screw. So this ball screw is a little coarser than the one that was on it, which is actually nice because it allows me to run a little bit faster because the input scale, the counts per inch now are lower. It was 50,800 and now it's 37,000 something. Let's take a look here. Yeah, 31,750. So with this base thread, that allows me with a little headroom to run 90 inches per minute. And on this little lathe, that's probably a pretty good clip. I think the original did like 18 or something like that. I don't remember. So the other thing I found out is that PCIe printer port cards, parallel port cards, allow you to run just a slightly faster base thread than like a PCI one, which kind of makes sense, but I guess it surprised me. So with this card, I was running a 50 or a 22 microsecond base thread, and with this I can run 18, which again allows me with some headroom to run 90 inches per minute. So if we look at this, I can jog this back and forth at 90 inches per minute. That'd be more than fast enough for most things, I think. I'd be happy with that. And I'm still getting around, what's normal? Let's roll this. I'm still getting around 2/10 of following error. So yeah, 2/10. This is a tenth of a thousandth per division. So about 2/10. So I have the following error set to 1,000th of an inch. So Linux CNC will trip if the following error is greater than 1,000th of an inch. And so far with me just jogging this around, I have not had any following errors. I really hammer on it. So if I zero this, I can run just a program that runs it back and forth. All right. So this is what I use for tuning. This just runs this back and forth, and I can make adjustments to the PID settings here and test them out and see what's improving. it works really well. There's an auto tune that I'd like to try, but I just haven't gotten around to it. I think they've recently done some fixing to it, so might have to give that a try and see if how well that works. So, but yeah, let's see here. Yeah, even when it's going 90, it isn't 100% duty cycle. I really should put a bar graph here that kind of gives you the duty cycle of the pulse density modulation. It would be a neat thing to see. So, but again, I should tune it a little more and see if I can get it better. But again, 0.2 of a thousandth of following error, I'm pretty happy with that. So, like I say, I think I need to tweak a few things, but so far, I think it's all gonna fit in there. And you can see this. Can we see this running? Yeah, kind of goes back and forth. This is plastic, so once I get everything perfectly parallel, I think it'll be better. But yeah, so far so good. Still working very well with just a printer port. So talk to you guys later.